Okay, we're recording. So here it asks to solve for x, right? Or find the length of the segment indicated, which is indicated by the letter x, obviously. And it looks like there are 14 problems. So really what you need to realize is that when you have a segment from the center of the circle that's perpendicular to a chord, it's always going to cut in half. So these would be the same. If I were to actually label these points as A, B, C, segment AB would be congruent to segment AC. So hopefully that seems intuitive. So that's just 6, and that's just 3. Not that hard, right? This one is a little tricky for X. That's not going to be terribly obvious. Because even though you have a line that's perpendicular, it's not, this is getting cut in half, right? Not this. That's getting cut in half. The chord is getting cut in half. Remember, a chord is a segment that connects 2 points in a circle. The chord is getting cut in half when there's a segment from the center that's perpendicular to the chord. So here's a center, and when you have something that's perpendicular to the chord, it's cutting the chord in half, okay? The chord is getting cut in half. So in this case, if that's 31.8, half of that is going to be, let's use a calculator, I think 15.9. Yeah, so that's 15.9 right here. Oh, let's write that more nicely. That's 15.9 right here. So now I can use Pythagorean Theorem. Actually, I don't really need Pythagorean Theorem. I mean, I could solve for that stuff if I wanted to, but they're asking for this, right? Well, if you think about it, that's a radius also. And that's a radius. So then you could say 15.9 equals 7 plus x. So x would be 8.9. And just to make sure I don't look like a jackass, I actually got this right. There you go, 8.9. Sometimes I can make mistakes or look at things the wrong way. So same thing here. If that's 9.7, that's 9.7. So x is going to be 4.6. For over here, if that's 25.2 is the diameter, so this is going to be 12.6 over here. That's 9.7 right here. Then that's also 9.7 right here. Because remember, the chord gets cut in half when there's a segment perpendicular to it, or when there's a segment from the center of the circle that's perpendicular, or the radius. Obviously, that's a radius, right? Because it's coming from the center. So it's cutting the chord in half. So the radius, remember, the radius, if radius is perpendicular to a chord, this is the main concept here, then the chord is bisected, okay? So that means that this is also 9.7. So now you got yourself a right triangle. So it's a little more work you have to do for this one compared to the previous 4. That's 9.7, that's 12.6. Solve for x, not that hard. So 8.04. Okay. We're 8.1. Close enough. If we look at 6, that's a 9.4 because it's got a diameter. And that's 7.8. That's also 7.8. Actually, we don't really have to bother using that 7.8. Sometimes some information you don't have to utilize. If that's 9.4, that's 9.4. So x plus 4.2 equals 9.4. X is going to equal 5.2. You can see that's the answer for number 6. So a lot of these problems are going to work in that way. I'm just going to kind of briefly talk about how to approach the other ones because we can't go over every single problem. But here you have 4.4 and 8.3. You can call this C. Do Pythagorean theorem, and that will be the same as this one over here. And I believe we're going to do something very similar for number 7. This is apparently 10.6. They should have actually labeled it better. I think it's just closer to the edge. That's probably why it's just the radius, not the diameter. So if you thought it was the diameter, I guess if it's by the center, that's the diameter. But if it's closer to the edge of the circle, I guess that's just the radius. Sorry, that's just going to be half the length. That's what I meant to say. So yeah, if that's C, you do the same thing. I could see this. Pythagorean theorem again. Number 9. That's 10.8. That's 10.8. Pythagorean theorem again. Number 10. There's a lot of Pythagorean theorem stuff going on here. And then for the last 4 problems, that's 15. That's 15. I'm not sure if that helps us. I know this whole thing here is 16.7. So you probably could do is draw this. This is the part that's not terribly obvious. Sometimes you have to add to the diagram. So that's 16.7 right here. So I'll call this like, say, A. You do Pythagorean theorem for this. And then A plus X has to equal 16.7. So you got to solve for A by using Pythagorean theorem, which is just that. Once you solve for A, then you can solve for X using this, because A plus X is the radius. That's 12.8. That's 12.8. Yeah, you can use Pythagorean theorem to solve for A here, and then this right here equals 15.1. So 12 is very similar to 11. That equals 15.1 because 15.1 is a radius. And then, yeah, I'm guessing you probably just do the same thing. That's 18.9 right here. Call this A, do Pythagorean theorem, solve for A. And then A plus X equals 18.9. And for 13, 30 is right in the center, so I'm guessing this is probably 15. There's also 14.1. Call this A. We're going to use Pythagorean theorem to solve for A. And then A plus X will equal the radius, which is 15. All right, so that's all those problems are down. Again, this is being recorded, so you guys will have access to this recording, so you guys can view this again before our test this Thursday. Any questions on this worksheet before I move on to the next one? Or anything you want me to explain again? All right, we'll keep moving. Arcs. This might be, well, I don't know if it's easier, but we shall see. Let's see here. FQE. You're asked to name the arc. Oh, okay. That's good by the given angle. Oh, you just say arc FE. When you just put 2 letters, you assume the shortest distance between the 2 letters. Of course, FE could go that way, but then you gotta say FDE if you said that. So angle 1 is arc HI. Then you go the other way around. If you're given the arc, if the angle that goes with that's angle 1. And this here you say angle MQL. Because here's ML and here's ML. So angle 1 or angle MQL. Okie dokie. Keep moving. If an angle is given, name the arc it makes, or if it's the arc is given, name the central angle. So remember, central angle means that the vertex is at the center of the circle. So that's what this means. Vertex is the center of the circle. So if you have arc RS, then the angles of angle SQR. Okay. Major arc for angle 1. So major arc This is going to be this. Actually, it's not that hard. You just have to name the arc. So it's going to be arc BCA. Major means it's more than 180. So major minor okay. So angle KQL. So that's just RKL. Then arc SVT. That's kind of weird. I say it's angle TQS. I'm not sure actually would say it's TQS. That's kind of weird actually. That's a major arc, obviously. Let's see what the Ansky says. That's kind of weird. That's weird. Don't worry about that one. Then we got stuff with numbers. That's 120. Remember, central angles always equal to arcs to intercept. That's 123. So you have to find the measure of the arc or central angle is indicated. So they're always going to equal each other. Arc or the central angle equals arc. It intercepts. Intercepts meaning like what it covers. So CFD all the way around like that. That is a little tricky. Give me a sec here. Let me think this one through. Okay, that's also 135 because that's 135. So then if you have 81 here, that's going to be 54. So then you got 270 covered, so you have to have 90 left over, so 45, 45. Yeah, I think that's right, because you have to have 90 left over. Yeah, that makes sense, because that's 135. That has to be angle F, or this one right here, that have the double markings. That has to be 45 to form a linear pair. Yeah, that's what makes sense. So you get 90, 225. Yeah, okay. So the angle CFD would be 360 minus 54. Sorry, arc CFD would be 360 minus 54, or 306. Nina, go ahead. You have a question.
So that was an accident.
I'm sorry. What was that?
I'm sorry, that was an accident.
Oh, okay. No worries. Got it. All right. Then number 12. Let me recenter that. Yeah. So if that's 86, that's 86. Okay. And that's 154. That's 300. Just get 30 left for each of these here. If you add it all up, you get 146. Yeah, you get 146. For 13 EFC, if that's 126, that's 54. That's also 54. So you got 126 up for these two. So that's going to be 63, 63. So if you want arc EFC, that's going to be 234. And then this one here, MIJ, so if that's 55, that's 55. Hold on, Ann, give me a sec. Angle MIJ, that has to be, sorry, that's a 55. Ugh, that's getting ugly. Remember, arcs and central angles are equal, but MIL is also 55, and then therefore this has to be 125. Okay, go ahead, Neil, you have a question?
How did you get 54 for number 13?
Well, you subtract 180 by 126. And the reason why you want to do that is because that's a line. So 126 plus that angle that I just marked up has to add to 180. That's like a 54. Therefore, that's 54 because those are vertical angles. And then you have 126 left for the remaining two angles, and they're the same because they have the red markings. So you do 63, 63. Yeah, you want arc EFC, add them all up, you get 234.
Thank you.
Yeah, no problem. And then these fun ones with variables. If that's 140, that's 40. Because again, that forms a linear pair. So 6x minus 8 must equal 40. I trust you guys can solve that just fine. These are the same, and that's a diameter. So this has to be 90 degrees. So 90 equals x plus 93. For 17, 12x minus 2. Well, first of all, this is also 5x plus 10. Okay. And these are two lines that intersect. So this is also 12x minus 2 because it's the same as the arc it intercepts. So 12x minus 2 is going to equal 5x plus 10 plus 5x plus 10. The reason I'm adding 5x plus 10 twice is because that makes up this part over here, which is equal to 12x minus 2. And they solve for x after that. And then once you solve for that guy, so that's gonna be fun. Maybe we'll actually work this out. We want getting 10x plus 20 on this side, and 12x minus 2 on this side. You get 2x equals 22, x equals 11. If x is 11, then you get 130 degrees over here. So this has to be 50 degrees to make it 180. I believe that is correct, 17. Yep. So definitely these are more involved problems. Good problem solving skills being on display here to do these problems. And then angle VST, that's the same as VSU. So yeah, so this is also negative 27x minus 3. And then 37x plus 2, another, so these are the same, obviously, arc TV and arc VU. So all those added up have to have the 360, that's the full circle. Must all equal 360. So then what do we got? Let's use a calculator. There's a lot going on there. 27 times 2 plus 37. So negative 91x minus 4 equals 360. Negative 91x equals 356. That is a really, really nasty number. Hold on one sec. Is it really that nasty? Negative 6. Oh, shoot. I have to add 4. Yeah, see, it's always good to double check your work. So 364 divided by 91. So much better. X is negative 4. Got it. So if X is negative 4, and you want angle VST, so you're going to plug in negative 4 into that expression. For it to be 108 minus 3, you should get 105 degrees. So let's get if x is negative, just the angles or arc itself's got to be positive. Yep, 105 degrees. Okay, so that covers arcs. Any questions? Or anything you want me to redo or look over again? Okay. And the last one on tangents. So remember the key concept here is that the tangent line, which touches the circle at one point, the only one point, so it's like raising the circle, is always perpendicular to the radius. So if you're asked to determine if it's a tangent, you're going to have to do Pythagorean theorem to see if it's satisfied. So 12 squared plus 16 squared, does that equal 20 squared? It will. So that's yes. And then you kind of do the same thing here, 6.6 squared plus 11 squared. Does that equal 13 squared? Okay. And you kind of go through the same motions for all the other ones. I think 3 will be a yes. 4, I'm not 100% sure, but just do Pythagorean theorem. Let's look at the answer key, what the answer key says. It says tangent, tangent, tangent for number 4, but not tangent for number 2. Okay. And then here, they are tangent. I'm told that. Just got to find the missing side. So again, it's all just Pythagorean theorem stuff. Not that hard. If I call this like x, 4 squared plus x squared equals 8.5 squared. That's 1.5, by the way, for number 6. So 1.5 squared plus x squared. And then that whole thing here is 2.5, the hypotenuse, equals 2.5 squared. Here, 12 squared plus 16 squared equals x squared. Or here, well, that's interesting. I guess that's going to be 6 then. So 12 squared plus 6.4 squared. I'll label that better for you guys. Equals x squared. You work those out. I trust you guys can do the Pythagorean theorem just fine. So you see it's an extension of things we've done in previous units. Let's keep moving. Okay. Yeah, here again, you assume that these are tangent. So that's a right angle right here. Before I even do that, I know this is 63 right here. That's because you have 2 radii, right? So it's an isosceles triangle in the middle. So this is going to be 27, because remember, the tangent line and the radius are perpendicular. That's a right angle right there. I'm actually doing a different color, so it stands out. Okay, you got a right angle right there. And that's going to be 117, because you have a linear pair, right? You know, 63 plus 170 gets you 180. And then you got one more triangle to consider, this right here. We have 27 and 117, which is 144. You do 180 minus that number. That's 36 degrees. Here we got a right angle. Oh, yeah, go ahead, Nina, question?
Where'd you get 27?
Because, let me back up. There's a lot going on there now. You see how that's a right angle?
Yes.
Okay, good. That's a right angle. And then also, do you see how that's 63?
Yeah.
Okay, good. So you do 90 minus 63
to
get that little sliver there. That's how you do it. There's a lot going on, obviously. So, but yeah, so we're going to be doing a lot of that kind of stuff. Like for 14, for example, that's a right angle. So I know this is 46 because the whole big triangle here has to have 180, right? All the angles. And these are the same. You know, those are both radii. So that's 46. So you get 92. So this has to be 88 right here. So it's kind of like this chain reaction. Once you kind of figure out one, all the dominoes fall, right? So that's 88. Here you can cut in half. The reason why I could do that, these are going to be the same because we're told that when you have an external point that creates two tangents, those two tangents are equal. And these are things, these are both radii, and these are both right angles because they're tangents. So the triangles are congruent. So that means that then this will be half of 117. What is that? That's 58.5. That's also 58.5. 90 minus 58.5 is going to be 31.5. That's also 31.5. So it becomes 63 degrees. There is a rule that says that when this happens, let me go and clear my screen for a sec, that these two add up to 180, but I don't want to just tell you that. I want you to see why that would happen. So if I kind of backtrack again, this problem. These are the same. And if I connect this, I got right triangles here, and these are the same. So I have by hypotenuse-Lake theorem, these two right triangles are congruent, meaning that these angles, all corresponding parts are the same. So you can split 117 as 58.5. And then, of course, you do 90 minus 58.5 to get the remaining angle, and then double it, you get 63. That's a right angle right here. Again, you have another tangent, so therefore this is going to be 38 degrees. That's also, these are both radii, so this is also 38 degrees. So that's 76. So it's 104 degrees. Okay, 104 degrees. Okay, that was a lot of work review. Any questions? Okay. The video is probably better than just giving a solution key, because I mean, if I didn't do all my work, I mean, I guess I could kind of show you all this. Maybe that, I don't know if that would help. But I think watching the videos and seeing the process helps. I think that's more powerful. So you'll have that, and I would strongly suggest you watch that part, this first part, when preparing for our test this Thursday, because that's pretty much what we did Friday, right? And the test is going to cover, you know, all chapter 10, all chapter 11. So this is just 1/4 of the stuff so far. We still got more to cover today. We got stuff to cover Tuesday, Wednesday also. Chapter 11, don't know what that's about. I'm just kind of curious. What is chapter 11 about? I should know this, but anyway, I mean, I do know the material. Just, well, area, that's not gonna be too bad. That's gonna be, yeah, that's not too bad at all. That's very formulaic. Yeah, I think this will actually be pretty easy. Okay, let me shut these down. No, don't shut that down. Shouldn't we reopen 10.7.2? Okay, cool. So now let's move on to 10.4, because we need to talk about a new topic. We'll see how far we get. Highly doubt I could squeeze in 10.4 and 10.5 or 10.15. We shall see if I can make that happen. Maybe I just do 10.4, do a break. Then we'll kind of power through 10.5, 10.6, 10.7. Then we do the worksheet after lunch. That's kind of my thinking here. But a little warm up. So it's just solving stuff, not that hard. You could distribute that 1/2. If you do that, so x equals 6. There you go. Or if you want to, you could multiply both sides by 2. That also works. So just not worry about that. I don't care for that stuff. All right. Okay. So let's talk about the concept here. This is a concept that some people tend to forget. It's not reinforced terribly much. Neil, go ahead. Question.
Could you go back, please?
No problem.
Thanks.
Let me just so that's the second way I did it, where I multiplied both sides by 2 to get rid of the fraction. You get 6x equals 4x plus 12. But also, let me undo. You get done that way also, where you distribute the 1/2. That's not such a bad technique as long as the numbers come out nice. Like if I had like a 1/3 times 4x plus 12, then you'd have a fraction. I'd like to avoid fractions if we could. So anyway, that's that. Okay, inscribed angles. An inscribed angle is, as the name's implied, just an angle inside of a circle. That's all. So that angle right here is inside the circle. And there's an arc that intercepts, just the arc that passes that it creates. The key idea, this is the key idea. If I call this x, the arc is going to be 2x. So the angle is always going to be half of the arc that intercepts. So if this were, for example, 30 degrees, then this would be 60 degrees. That's why we have the 1/2 there, because 1/2 of 60 is 30. So you can think of it like that, that the inscribed angle is always 1/2 of the measure's intercepted arc, or the intercepted arc is twice the angle that's inscribed. Vice versa, the same thing. So in this case, let me get a highlighter. That is going to be 100 degrees. Arc QT is 100 degrees because the angle that's inscribed is 50, okay? Let me get another highlighter out here. That's 48 degrees. That is going to be 24 degrees. Okay, that's going to be 24 degrees. So angle T is 24 degrees. Arc QR, so if you think about it, if I go from here all the way to here, that's a semicircle, it's 180. So arc QR is going to be 80 degrees. 80 degrees, okay? So there we go. Okay, cool. Questions on this one? Okay, what do measures angle T and U have in common? They both intercept the same arc. Let me type that up. Both angles T and U intercept the same arc. That's arc SR. Okay. Yeah, so if I were to just quickly trace. See that? And we'll trace again. They intercept the same arc. So what this means is that angle T is congruent to angle U. So angle T will also be 31 degrees. And this arc, by the way, is 62 degrees. Right? Because we've talked about this already. The inscribed angle is half of the arc it intercepts. This is when the vertex sits on the circle, not the center. Okay, so we've seen this already. Okay, that's a terrible looking circle. Do better than that. Okay, a little better. Like for example, if this were 100 degrees, then that's 100 degrees. Okay. If two inscribed angles of a circle intercept the same arc, they're congruent. We just talked about that. So that's a theorem. So you're asked to find the indicated arc or angle. That's going to be 45 degrees because half of 90, that's 76. The arc is always double the inscribed angle. So this right, let's get a highlighter out. That is going to be, this will be a W, by the way. There we go. So that's 144 degrees right here. So this is going to be 72 degrees. Because it intercepts arc CW. So angle Y and angle X both intercept. So both angles Y and X intercept arc ZW. Okay, questions on those? Okay, last concept. And maybe we could do a little bit of the worksheet that follows this. So just so you guys get some practice. Any type of polygon where all its vertices lie on a circle. Okay, that's an inscribed polygon. Okay. Okay. So all the corners touch the circle. And what's going to happen is that the opposite angles add to 180. So D and F add to 180. E and G add to 180. Why is that? The reason why that's going to be true, let's draw this right here. Here's the center. Let's have something like that there. Okay. Didn't do a good job drawing that. Let's try this again. Let me draw the diameter first. Okay, let's say you have something like that there. What's going to happen is that's going to be 180 because I did a semicircle. So it makes that 90 degrees. And then what if I look at this? That's also 180. And if I were to draw that, that's also 90. So now we see that both these add to 180. Of course, there's a possibility you could draw a quadrilateral where this diagonal does not pass through the center, but it won't matter because what's going to happen is that both of these arcs, this arc right here and this arc right here, are going to add 360. And then this angle and this angle are intercepting the yellow and green arcs. And so that's why when you take half of 360, you get 180. So these two angles would add to 180. That's the reason why this theorem holds true. So opposite angles of an inscribed polygon will add up to 180. So in this case, that's 100, because that's 80 right there. And in this case, y is 95. Nope, 1 to 5. For this one, let's color code this. So 2a plus 2a, come on, equals 180. And 4b plus 2b equals 180. 4a equals 180. A is 45. 6b equals 180. B is 30. Okay, so why don't you guys try these two really quickly? Should be pretty fast. So hopefully you realize that you need these two to add to 180. So you should get 98. And these two right here, you should get 112. Here, you should have 62. And here you should get 10. Just double check that. Yep. Okay, I think we have time to do a little bit of the worksheet so you guys get some more practice on this, because I don't want to overwhelm you with too much information without some practice. So here's a worksheet for 10.4. So if you go to Schoology, click on chapter 10, and you'll see the theorems definition we just did, and then the classwork is what you want to do. And that's how this is all set up. Like there's the theorems definitions that we're going to cover, and then the classwork that follows. So why don't you guys work on just the evens. So 10.4 worksheet, just the evens. And you're asked to find an indicated measure. So here you're supposed to find angle G. For number 4, you're supposed to find arc of RS. For number 6, arc WX. For 8, solve for the variables you see there. And 10, solve for X. So I'll give you guys about 7-8 minutes. We'll talk about it, and then we'll probably do a break closer to 10:10 today. So you guys, let me pause the recording. Okay, so just the evens. So angle G, you want to find this angle. Well, if that's 120, that's 70. Getting a highlighter out here, that is going to be 170. You need everything up to 360, right? Therefore, this angle G is going to be half of that, or 85 degrees. 4 is a little easier. Arc RS, which is this right here, is double, so it's 134 degrees. Number 6, WX, which is actually hidden down there. Well, first, if I know that's 150, because that's double 75, and you got yourself 110 as well. So that's a 260, so that's 80 degrees right there. So hopefully those make sense for 2, 4, 6. Any questions on those at all? So 85 is the answer for number 2, 134 is the answer for number 4, and 80 is the answer for number 6. Nina, go ahead. What's your question?
I'm confused with how you got 170 for number 2 and how you got 80 for number 6.
Let me reposition my screen because some of the corners are hidden. Okay, so yeah, let's do this again. So you see how those are add up to 190, right? So then we need to figure out what that's going to be. So what do all the arcs have to add up to? $360, right? And these two add up to 190. Wait, no, wait, did I make a mistake? Hold on. What did I have? Did I make an error? Shoot. No, I got it. Yeah, okay, sorry. I thought I put 150 accidentally. Yeah, I got it. So you have that, right? So that's 170 degrees right here. And then that has to be half, right? Because that's the theorem. Inscribed angles are half the arcs that intercept. And then for this one, that right there is going to be 150 because that's double 75. So if you have 150 and 210, 150 and 110, you got 260. Oh, shoot. Did I make an error? Darn. Did you get 100 for WX? Should be 100, not 80. My bad. Yeah, it's doing a little too fast. So 150 plus 110 is 260. So you have 100 left for WX. Yeah, sorry for that mistake there. But I'm pretty sure I got number 2 right the first time around. Yeah. Okay, let's keep moving. So we take a little break. Number 8. Opposite angles are the same. Sorry, they're not the same. They add to 180. So they're going to be supplementary. So that's 120. And then this right here also add the 180. So K is 60. So remember, the opposite angles are supplementary when you have an inscribed polygon. And then here, this angle, 8x plus 10, has to be half of the arc it intercepts, which is 12x plus 40. X equals 5. Okay. So you have the odds to do for homework. Or if you want to do the odds in a break, go ahead. But that's going to be part of homework. So let's come back at 10:25, let's say. Yeah, 10:25. We'll definitely, I think, be able to get through 10:5 and 10:6. And because I am kind of doing the worksheets afterwards, maybe after lunch break, then we'll do 10:7. So let's take a break right now. If you do want to stick around, if you have any questions, please let me know. Let me pause the recording. Okay, now we're going to talk about other angle relationships in circles. So our plan is to do 10:5 and 10:6 before our lunch break. We'll do a lunch break around 11:30ish. And then we'll come back from lunch break. We'll do 10:7. And that'll wrap up the class for today. So we are going to do a little bit of the worksheets following each lesson. So the 10:5 worksheet, again, we'll do the evens. The odds will be homework. The 10:6 worksheet, we'll do the evens. The odds will be homework. And the like goes to 10:7. Okay, so here we're asked to solve an equation. It's a quadratic. And let's just not worry By the way, if you were to rearrange that, I think it comes out to England, which of course is a country, but yeah, let's not worry about that. But this I care more about, factoring. So what you want to do is find two numbers that multiply to 20 and add to 9. Well, if you do not that many numbers that multiply to 20, I mean integers, right? 1 and 20, 2 and 10, and 4 and 5. Or you can do -1, -20, -2, -10, -4, -5. It's going to be 4 and 5. And there you go, x plus 4, x plus 5. And then if you solve it, you get -4 or -5. So either answer would work. So we might have to do some factoring down the road. So look at 1011. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so this is kind of a little complicated. Let me explain that because I read that kind of fast. So if you have a tangent line, which is this right here, so if I were to draw a radius, it would be perpendicular, but we don't have a radius, so don't really worry about it. But if you had a tangent line, which is the black line that's crossing or touching the circle at point A, and you have a chord, AB is a chord. So AB is a chord. Let me actually clear my screen and kind of center this. So again, there's a tangent line. Touching a circle at point A. And that's a chord. Okay. What's going to happen is that the angle they form, so angle 1, will be half the arc it intercepts. So, for example, if this were, say, I don't know, 40 degrees, then that'd be 80 degrees. And by the same token, let's say angle 2 or like say 100 degrees, and the arc, which is blue, would be 200 degrees. So let's take a look at the examples down below. You're asked to find the measure of angle B. So the arc is 130. So for angle 1 is 65 degrees. Okay, that's all. We're here. You're told this angle is 125, so the arc is going to be 250. KJL is a label in red, obviously. Arc KJL, so that's 250. And again, measure of angle 1 is half of 130, or measure of angle B. Questions on that? Okay. So you guys try, and then we'll talk about another topic. What is angle 1 going to equal? What is arc RST going to equal? And what is arc XY going to equal? So I'll give you guys a moment to figure that out. Okay, so angle 1 is going to be 105 degrees. Kind of like the temperature yesterday. I mean, different, obviously, unit, but yeah, that's half of 210. Arc RST is going to be double of 98, so that's 196. Then arc XY, you assume always the shortest possible distance, unless they put another letter here or tell you to do a major arc. That's 160 degrees. Because the angle that's formed there is 80. Okay. These other ones are a little tricky. These are ones that I sometimes forget. If you have two chords that intersect, so here's chord AC and chord BD, then this is a little tricky. The measure of each angle is 1/2 the sum of the measures of the arcs intersected by the angle and its vertical angle. Okay, that sounds a little confusing. Let me help you guys out with this again. So here's angle 1, and obviously angle 1 could be there also because those are vertical angles. So angle 1 is half the sum of the arcs they intercept. So angle 1's clearly intercepting AB and DC. So angle 1's half the sum of AB and DC. Sum means adding up. So for example, if this were, say, 100 degrees, and say this were 40 degrees, so arc DC is 100, arc AB is 40, then angle 1 would be half of their sum. Or half of 140, which is 70. And then I think this, I just totally are making this up, but this were like, say, 160, and say this were like 100, then angle 2 would be half of 100 plus 160, which would be 130 degrees, by the way. Because 100 plus 162, 60, half that's 130. So, and AD is obviously right here, and BC is right there. So that's all that's going on there. So we try some of these here, like say if that's 130, that's 156. So this angle obviously is forming this arc, and right across from it is that arc, right? So by the angle is vertical angle, because the vertical angle is obviously right here, that's also X. So if I were to add those up and divide by 2, that's what X is going to equal. That's 286 divided by 2. You should get 143. Okay, go and figure out what you think Y will be. Hopefully you recognize that this will be 78 degrees. So 78 degrees will equal 1/2 of the arcs that are intercepted, which is 95, and Y. So you multiply both sides by 2. And you solve for Y, I think you get 61 degrees. Questions? Now I'll make sure you guys have a formula sheet for our test, because there's a lot of formulas in this this unit. That's one of them. Okay, let me go and clear. We have 3 more. These were kind of a doozy. So, and they're all pretty similar. So like these angles are half of the difference of two other arcs, but they're two different scenarios. So this scenario is a secant with a tangent. That's right there, two tangents. And that right there is two secants. Okay, so BC minus AC. For example, this were like, say, I don't know, 140, and this were 40. If you took the difference between those two, that'd be what, 100. Half of 100 is 50. So anyone's 50 degrees. Here you got two tangents. Both these lines are touching just one place. So that's going to be 200 degrees. And that would be 106. Well, I'm just totally making this up. Let's say there's like 260. And there's like 100. Not obviously the scale. Actually, let me take it back. Let me do 240 and 120. There we go. That's a little more to scale. So then obviously if I do half of that difference, half of 120, I get 60 degrees. And then this one here, you have two secants. Say this were 100, and say this were like 40, then angle 3 would be 100 minus 40, or 60 degrees. But you gotta take half. Let me back up a little bit. $30 degrees. So here, X would be half of the difference between those two, because you got a tangent and a secant. That's 102, I think. So you get 51 degrees. And here 30 gives half of A minus 44. It clearly is bigger than 44. 60 equals 104. Because 104 minus 44 is 60, half of that, of course, is 30. Okay. So any questions on those two? Okay, let's do some stuff in the worksheet. So here, very similar problems to what we just had. There are 9 problems. Just do the even. So do 2, 4, 6, 8. So definitely do number 2. You got to find the measure arc DEF. Number 4, find the value of x. Number 6, also find the value of x. Looks like x is an arc, whereas x is an angle for number 4. And for number 8, solve for x. Okay, not very obvious, but you got to solve for x there. So that one's kind of interesting. Okay. It looks like this. It's that center. A is the center of the circle. Okay. Okay, that'll be interesting. We'll see how that one goes. It's not coming right away, but we'll work through it. But yeah, try to work those out, and we'll talk about. I'll give you guys like 5 minutes. So 11 o'clock, we'll go through the answers, then we'll start 10-6. So I'll pause the recording once you guys work on 2, 4, 6, 8. Okay, let's go through the events, and we'll start the next one. So DF. So that's 117. So DF will be double that, will be 234. So again, you have a tangent line of the chord, where we talk about that. The angle formed between the chord and tangent line will be half of the arc you intercept. Next up. So that's 145, and that's 85. So x will be half of the sum of those two. So we talked about when you have an angle formed by 2 chords, the 2 arcs that are intercepted by the angle and its vertical angle, x will be half of the sum. So that's 230. Half of 230, of course, is 115. Oh, I don't know why I'm doing number 5. You guys can do 5 for homework. So that's number 4. Hopefully that makes sense. Number 6. So we talk about when you have a tangent and a secant, this angle is half of the arcs that are intercepted, of the difference of the arcs that are intercepted. So you don't know x, but you do know 114. You know the bigger arc, not the little arc. So you got to work that out. So 58. So x is 114 minus 58, which will be 56. So we 56 degrees for that one. So that's number 6. Then number 8. Let's see here. See, that's third. This is an arc, so that's 30. And that's another arc, that's 80. I'm not sure if it would help. Well, I know, I know that's 80. This would be 25 degrees, by the way, because you do 80 minus 30 and then half. So this is 80. And just to not make this too busy, that's gonna be 100 right here. Okay. So it means that this is 40. And that's 40. And that makes sense because 40 is half of 80. So that makes sense, okay. Oh, yeah, here we go. Got it. Yeah, this is a tricky one. This is gonna be 100 degrees right here. Let me get a highlighter. That arc is 100 degrees. So then this has to be 50 degrees. And how do I know that's 100? Because this is a semicircle. You have 80 right here, so you have to have 100. So actually I didn't even need to bother with that part. That was not even necessary. Or even that part as well. But it is good to know that's 40 because you have a tangent to the diameter or radius. So x has to be 50 anyway. So there's a few ways you could look at it. But x is 50. Okay, so let's move on to 10.6 where we do a lunch break. Any questions on this? Okay. All right, find segment lengths in circles. So it's kind of similar to what we just did, but now segments, not with angles or arcs necessarily. And then we'll do a worksheet on this. Again, we'll do the evens. Okay. If I were to FOIL this, that'd be x squared plus 8x plus 12x plus 96. Or x squared plus 20x plus 96. So FOIL means first, so x and x is x squared, outside, x and 12 is 12x, inside, 8x, last, 8 times 12, 96. So x squared plus 20x plus 96. And let's just cross that off. Okay. So x squared plus 20x plus 96. So now let's talk about some of the concepts here, because we're gonna have to use that skill for some of these problems here. And actually, coming to think, I don't think we did any factoring. So, don't know why there was a factoring thing in 10.5. So coming back to 10.6 again. If you have two chords that intersect, and diameters are chords too, by the way, just happens to be the longest chord, just a chord that goes to the center of the circle. If you have two chords that intersect, then the product of one of the chords broken up, so you have AE and EB, that product is going to be the same as the product of the other two chords, or sorry, the product of the other chord broken up. So if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord, so AE and EB are the segments of one chord, is equal to the product of the lengths of the segments of the other chord. DE and EC are the segments of the other chord. So like for 10.6.1, x plus 2 times x plus 1 equals x times x plus 4. And then you have to solve for x. So you're gonna have to FOIL the left side. There'll be x squared plus 2x plus x plus 2 equals x squared plus 4x. The x squares cancel on each side. So x equals 2. Because you move this over to the other side, x equals 2. And that makes sense because this would be 4 and 3. That'd be 2 and 6. 4 times 3 does equal 2 times 6. So 3x equals 24. There we go. 3 times x equals 4 times 6. Not that hard. X equals 8. This next one, the next two are kind of a doozy again. So here you have two secants, and you have these external segments, EA, then AB is internal, and EC is external, CD is internal. They say here, you take the product of the lengths of one secant and its external segment equals the product of the lengths of the other secant and its external. So if you take EA, that's external, and the whole thing, which is EB, that product is going to equal EC times ED. So for example, say like 4 and 6, totally making this up again. Hold on, see if that makes sense. I think so. Hold on a sec. I'm trying to reverse engineer this in my head. Yeah, so you take EA, which is 4, and EB, which is 10, equals EC times ED, which is 8. 40 equals 40. We're A-okay. All right. So here you would do 4 times 9, because 4 plus 5, equals 3 times 3 plus x. So 27 equals 3x, x equals 9. And that would make sense because you have 4 times 9 equals 3 times 12. Then here you're going to do 6 times 6 plus 9. Because you're doing this with all this add up. Equals 5 times 5 plus x. So 6 times 6 plus 9 equals 5 times 5 plus x. And you get 13. And that would make sense because if I double check my work, you have 6 times 6 plus 9, which again is 90. And then 5 times 5 plus 13, which would also be 90 because you get 5 times 18, which is 90. Okay. Here, this is also kind of where you have a tangent and a secant. So it's kind of the same thing as what we just did. You're going to do EC times ED, but here you have a tangent, not a secant, so you just do EA squared. So like, for example, if this were like, say, I don't know, say 6, I'm just trying to think here, 4 and 5, then 6 squared would equal 4 times 4 plus 5. So 36 equals 36, and we're A-okay. So you do the same thing here. 16 squared equals x times x plus 8. So you just follow the formulas. That's all. It's 256 equals x squared plus 8x. Okay, here we're going to have to do some factoring. That's not a terribly easy one to factor. So you got to find two numbers that multiply negative 256 and add up to 8. So like 1 and 256, but one has to be negative, so forget it. Negative 2 and 128, forget it. We're getting warmer though. This is where you might want to use a calculator. Negative 4 and 64, no. Yeah, let's use a calculator. What's 256 divided by 8, if that's even possible? 32, so getting even closer. X times x plus 8. Yeah. I have a quad form program. See if that. Oh boy. Okay. That was kind of weird. I don't imagine I'll give you one this challenging. But yeah, that actually came out to a really weird number. You can't factor, unfortunately. So you have to use quad form, which you may remember from Algebra 1. And I could probably tell you what it's going to be. I have a formula, my calculator. Yeah, it's like 12.49. Yeah, so you have to use quad form, but I'm not going to work that out. I do the ones that are a little easier. Let's like this one here. X squared equals 1 times 1 plus 3. So x squared equals 4, x is 2. Then here, you're going to say 7 squared equals 5 times 5 plus x. So 49 equals 25 plus 5x. 24 equals 5x. X is 4.8. So yeah, that's 10.6. So now I'm going to give you guys about 8 or 9 minutes to try these problems here to have a chance to practice. So again, you're going to do the evens. So number 2 is you have 2 chords intersecting. You have a formula in the notes to go over that. Number 4, you have 2 secants. We have a formula for that, as well as number 6. Number 8, we have a tangent and a secant. And don't worry about 9 is going to be part of homework. So you're just going to do 2, 4, 6, 8, solve for x. I'll give you guys probably about 5 or 6 minutes We'll talk about it, and then we'll do a lunch break right around 11:30. Okay. So let me pause the recording. Okay, so for number 2, you're going to say x minus 3 times 9 equals 10 times 18. So 9x minus 27 equals 180. 9x equals 207. That's kind of nasty, whatever that is. Oh, never mind. It doesn't come out nasty at all. It's 23. Yeah, you can see number 2. Oh, obviously it's not there. It's such odds. Okay. So yeah, 23 for that one. So again, you just do the 2 chords. Sorry, the segments broken up from the chord. That product is equal to the product of the other 2 segments, 10 times 18. For number 4, you have the external segment, so 8 times 8 plus x, the whole thing, equals 6 times 6 plus 10. So that's going to be 96 on the right side if you use a calculator. And that's going to be 64 plus 8x. 8x equals 32, x is 4. So x is 4 for that one. That makes sense because you'd have 6 times 16 equals 8 times 12. So, okay. Number 6. 5 times 5 plus 7 equals x times x plus 4. Remember the external segments times the whole thing. So 5 times 12 equals x squared plus 4x. 0 equals x squared plus 4x minus 60. 0 equals x plus 10, x minus 6. X is negative 10 or 6. Negative 10 or 6. But you're not going to go with a negative number because that's kind of weird. So we're just going to stick with 6 then. And just to be sure, 5 times 12 equals 6 times 10. It sure does. We get 6 equals 60. Okay. Okay. So then number 8, 24 squared equals 12 times 12 plus x. So you get 576 equals 144 plus 12x. Which would be 432. Remember, that's the concept here, and then divide that by 12, you get 36 for x. And if you were to check it out and plug in 36, it would work itself out. Okay, so again, very formulaic stuff. Just good problem solving skills more than anything else. This is not stuff that you're really going to need in Algebra 2 or any future class, or even on the SAT or ACT. Even if they were to ask us on the ACT, they would give you the formulas anyway, because those formulas are pretty hard to remember. But yeah, that's that. So when we come back, we'll work on 10.7. So let's do maybe a 40-minute break. We'll go. We'll come back at 12. 15. Come back at 12:15. We'll cover the rest of 10:7. We'll do some practice problems, and then we'll end class. Hopefully, we'll end class by about 12:45. The homework is just going to be the rest of the worksheets, the odds, the rest of the problems on the worksheets from 10:4 to 10:7. So it shouldn't be too bad. It should be about maybe half-hour homework, if that, just so you get some extra practice at home. If you've done the odds already, great, more power to you. Then you don't have any homework, but that's what I'm going to expect you guys to turn in, is the odds for the 10:4, 10:5, 10:6, and 10:7 worksheets. Okay, let me close these down. We don't need these open. Let me stop sharing and pause the record. Okay, we're going to talk about writing and graphing equations of circles. So the area of a circle, in case you guys forgot, is pi r squared. Circumference will be 2 pi r. And the radius is simply the distance between the center and any point on the circle. That's the radius. So 225 pi equals pi r squared. Pi's cancel. R squared is 225. Square root both sides. R will be 15. So that's all. R is 15. And don't worry about this question here. It's kind of crazy. That's a little warm up. Now, the equation of a circle, if you want to graph it on a coordinate plane, is what you see right here. It looks a little crazy. X minus h squared plus y minus k squared equals r squared. H and k is going to be the center. R is going to be the radius. And there'll be some questions that we'll answer that use this formula. Before I do those questions, let me explain to you where the formula comes from, like why that equation makes sense, the equation of a circle, and then we'll do the problem. So I'm going to do a little teaching here with you guys. I mean, I'm teaching in general, but like more of a lesson that's not on the notes. So let me share a whiteboard. Okie dokie. So here we have a coordinate plane, x, y, right? X, y axes. And let's say this is h, and let's say this is k. And then say I've got a circle. Let me shift things around a little bit. Okay. And I've got a radius here, call it r. All right. So I got x, y as this point, and you're going to want to call any point on the circle x, y. The reason why is because we want an equation for the circle in terms of x and y. So remember our goal here. Remember what was our overarching goal? Our goal, come up with an equation in terms of x and y that describe, that defines, or that satisfies all points on the circle. Okay, that's the goal. Come up with the equation in terms of x and y that satisfies all points on the circle. So that's why the point on the circle I'm calling x, y. Then h and k is right here. That's going to be the center. Now, here's what I'm going to do. What if I draw a right triangle like that. I'll put the right triangle down below. The hypotenuses are, the legs are going to be x minus h and y minus k. Think about it. The x coordinate here is h. The x coordinate here is x from over here. So that distance is x minus h. And here you got k and you got y. So y minus k is going to be the length of the vertical leg, because the difference in the y coordinates between those 2 points. If I do Pythagorean theorem, a squared plus b squared equals c squared. That's a, that's b, and that's c. X minus h squared plus y minus k squared equals r squared. And that's all. That's where the equation comes from. So it's not something that fell out of the sky. It's actually using some coordinate geometry and also Pythagorean theorem to come up with that equation. So that's how you can always derive the equation. Drawing a circle, calling the center HK, any random point in the circle, call x comma y, because you want an equation in terms of x and y to satisfy all points on the circle. And when you connect the radius, and you know the radius is going to be the same because that's the whole definition of a circle in the first place, right? Is that you have a center point and it's going to be of equal distance to any point on the circle, and that distance is the radius. So the radius of the hypotenuse, x minus h is different x. There's a difference in the x coordinates that defines the horizontal leg. Y minus k is the difference in the y coordinates that defines the vertical leg. Sorry, x minus h is horizontal, y minus k is vertical. A squared plus b squared equals c squared. Or replace a with x minus h, replace b with y minus k, replace c with r. So that's the equation of a circle. Now let me go back to sharing my screen. And let's apply this for these problems here. Excuse me. So write an equation that with the following information. Well, you already have the center, so just plug and check. Or just plug in really and just write it out. That's it. For this one here, h and k are both 0, so you can just say x squared plus y squared equals 36. Done. So go ahead and try these 4 here really quickly. Give you guys about a minute and I'll share the answers. Then we'll do some more of the problems down below. Okay. So you should be getting this. X minus 4 squared plus y minus 2 squared equals 7 squared, which I know is just 49. And then this here I have x plus 3 squared plus y minus 2 squared equals 81. X minus 1 squared plus y plus 5 squared equals 169. And then x plus 1 squared plus y minus 7 squared. And if you square root 10 becomes 10. So any questions of those? Okay, keep moving. The next one's just the same thing, just have to identify the center. It's not explicitly told to you, but just look at it. The center's at -2, 2. And the radius is 3. Okay, so here we go for that one. Center here is at 2, 4. Radius is going to be 6, I think. Yep. So, yep, that's that one. Questions on those two? Okay, you guys try these here. Just give you guys about a minute. Shouldn't take long. So again, figure out the center. Figure out the radius. Center. Radius. Remember the equation is this, which I just derived for you a few minutes ago. Remember the center is h, k. And intuitively the races are. So center is at 2, -5. Race here is 3. Here the center is at 0, 0. And race is also at 3. So you got yourself x minus 2 squared plus y plus 5 squared equals 9. That's for this one. And this one here, because you have 0, 0 for the center, you can just say x squared plus y squared is 9. Okay, questions about those two? Okay, and finally graphing these. And And these problems you could make kind of more complicated, but these are going to be pretty straightforward. You have to identify the center first, and then the radius. Likewise, here is identify the center first. Then the radius. So the center here is 4, 1. Why? Because remember the equation is this. Okay. So you have minus, right? So you assume minus h. That's what you have 4. You have minus 1. So you assume 1 for that one. Then the radius is, of course, 3. Because r squared is 9. So radius is 3. For here, my center is going to be negative 2, 0. Because x minus h, right? So h has to be negative 2 to make that a positive 2. And of course, there's nothing to subtract the y, so you assume it's 0. And radius is root 30, which is roughly 5 point something. We'll say 5.5, not 100% sure. But I know it's more than 5 and less than 6, because root 25 is 5 and root 36 is 6. So then if you plot the points, 4, 1, go 3 away. And you draw a circle. Notice I went 3 up, 3 down, 3 left, 3 right. So it makes a kind of more accurate circle. Or if you wind up using say like Notability or something, you can make that do that. That looks a little nicer. And then this one here, center's at negative 2, 0. And you gotta go about 5 point something away from that point from the center. So probably we'll say 5.5. Doesn't have to be terribly accurate. Okay, and there you go. That's drawn. So it looks like the radius is about 5 point something. The center's at obviously negative 2, 0. And just to be sure, root 30, yeah, that was right, 5.5. It rounds to that. 5.477, a bunch of other random digits. Okay, any questions on how to graph those? Okay, why don't you guys try your own? I'll give you guys about a minute. And then we'll do some of these problems here in this worksheet. We'll do the evens, and then we're done for today. Okay. So again, the center here is going to be at 0, 0. If you don't see an H and K, the radius is 5. We'll kind of do freehand. Not as good as using the circle tool here. Here, your center is going to be negative 3, 3. So you do the opposite of the sign you see here, because x plus 3, you remember the formula is x minus h. So you need x minus negative 3 to make it a positive 3. And your radius is root 20, which is 4 point something. We'll say like 4.5, I think. And there you go. So questions about that one? Okay. So going to be pretty repetitive. Going to try 2, 4, 6, 8, 10. Again, here's the formula. So just the evens. I'll give you guys about 5 minutes. We'll talk about it, then we'll go over the answers and wrap up our class for today. Okay. We'll start putting the answers up. You don't have to simplify. Actually, that does simplify to 18, I believe. Okay, those are 2, 4, 6. Very straightforward. Okay. Number 8. Centers at 2, 3. Radius is 2. So you get x minus 2 squared plus y minus 3 squared equals 4. Okay, that's number 8. And then finally, for number 10, you're asked to graph this. Not too hard. Your center's at 0, 0 because you don't have h or k. And I'm doing freehand. Not gonna look great, but it's okay, we'll go with it. There you go. That's your circle. So hopefully that all seems fine. Again, this should be, I think it's the easiest topic we did today. Any questions? Okay. So homework again will be, and actually let me just create it right now, just so one last thing out of the way. Let me share my screen again. I'll stop recording.